8.1 Relations and Functions. For this lesson, the objective is to use graphs to represent relations and functions. A relation is just a set of ordered pairs. So, an example will be all these points here. The domain is a set of numbers called x-coordinates. So, the domain of the relation for this example here will be 0, 2, 3, 5. Please list them in order. The range are all the y values, so a set of numbers called y-coordinates. So all the y-coordinates in this relation are 1, 4, 7. And we do not need to repeat the 4. And again, list them in order. The input, means each number in the domain. So if we have an ordered pair, 1, 2, 1 is the input. For output, it's just each number in the range. So for the ordered pair, 1, 2, 2 is the output. And for the word function, it just means for each input, there is exactly one output. I will stress the meaning of this word as we move on with the lesson. Here we have a table. So 1, 2, 4, every single number are all the inputs, and 2, 3, 5 will be the outputs. To write them as an ordered pair, we will simply put parentheses around them. So 1 and 2, 2 and 3, 4 and 5. To plot these points, again, you take 1 here, 1, and move up 2 units. 2, 3, 4, 5. The horizontal axis of the graph is labeled with the input variable, x. The vertical axis is labeled with the output variable, y. So input, output. Is this relation a function? Let's see. The relation 1, 2, 2, 3, 4, 5 is a function. Again, remember, for every input, there is exactly one output. So this means that the x value cannot repeat. Otherwise, it will not be considered a function. So let's practice here. Identify the domain and range of the relation. Tell whether the relation is a function. So let's list the domain here. So we have 0, 2, 3, and 5. Notice how all these numbers or inputs are in order, listed in order. And for the range, 1, 4, 7. Again, we don't need to repeat. And again, put them in order. And for this problem, it is a function. Yes, because none of the x values repeat. For every input, there is exactly one output. So 0 to 1, 2 to 4, 3 to 7, 5 to 4. It's okay for the y value to repeat. Let's look at the domain here. We have -3, and then -1, and then we have -1 repeated. So we'll have to write it again. And then we have 6. Okay, and for the range, we have 2. Oh, 2 is not the smallest one. Negative 1 is. And 2, 0, 4. Let's see if this is a function. We have negative 3 to, no, not negative 3, negative 1 to 2, negative 3 to negative 1, 6 to 0, and then we have negative 1 to 4. Negative 1 repeated, so this is not a function. Not a function. Okay, and let's move on. Representing a relation and determining whether if it is a function. So here in this picture here, I graphed the relation. Okay, so we've got negative 1, 1, 2, 0, 3, 1, 3, 2, and 4, 5. Okay. The relation here is not a function because the input 3, 3 and 3 here, 3, 3, is paired with 2 outputs, 1 and 2. So this is not a function. Okay. I would also like to show you how to draw the mapping diagram. So you list the inputs and the outputs in order and draw the arrows from the inputs to their outputs. So X and Y. So you list all the inputs, negative 1, 2, 3, and 4 in the left-hand column, and then 0, 1, 2, 5 in the right-hand column. Okay, all these points come from this relation. And then again, draw the arrow, negative 1 to 1, 2 to 0, 3 to 1, 3 to 2, and 4 to 5. And notice 3 is paired with 2 outputs, 1 and 2. So not a function. Okay, these are 2 ways to represent a relation, using the graph and using the mapping diagram. Okay, guided practice. Represent the relation as a graph and as a mapping diagram. Tell whether the relation is a function and explain why. Okay, let's first graph it. Graph the points 0, 3, 1, 2, 2, negative 1, 4, 4, 5, 4. Okay, so maybe I should put a 1 here. 5, 4, yeah. Okay, so that's the graph, and let me do the mapping diagram. 0, 1, 2, 4, 5. Okay, they're in order. 0, 1, 2, 4, 5. And this one, you have 3, 2, negative 1, 4, 4. So I'm going to do negative 1 first, 2, 4. Don't have to write for 4 again. Oh, I mean 3, and then 4. And then we can draw the arrows. 0 goes with 3, 1 goes with 2, 2 goes with negative 1, 4 goes with 4, and 5 goes with 4. And notice that for every input, there is exactly 1 output. Okay, so this is a function. Yes. Yes, function. Just write an yes. Okay, and then on the next one, have to make it bigger. We have negative 2, negative 1, 0, 2, 2, 3, and then negative 2, negative 4, negative 2, 1, 2, 3, 4. Okay, and then that's the graph, and then I'm gonna do the mapping diagram. So negative 2, 0, 2, negative 2. So negative 2 is the smallest one, and then we have a repeat. Don't worry about that one. 0, 2. Let's see, you got negative 1, 2, 3, negative 4. Negative 1. Oh, negative 4 is the smallest one, sorry. Negative 4, negative 1, 2, 3. And then, let's match it up. Negative 2, negative 1, 0, 2, 2, 3, and then negative 2, negative 4. Uh-oh. Okay, you see we have the negative 2 here. It's paired with two outputs, negative 4 and negative 1. This is not a function. No, not a function. So the input cannot repeat. The x value can't repeat. Okay, now I'm going to show you a quick way to determine whether a relation is a function. So if you're given a graph, okay, for example, like the one here, and if you can draw a vertical line through every point and notice that there's no repeats of the x value, then the graph is a function. Okay, but if you draw a vertical line through every point and you notice that 2 points go through the same x value of 3 here, then it is not a function. And that is it for this lesson.